picking up what we left off last week, we use factorials to help us, or we use factorials and that way we can use those to help us determine how we can arrange different items mathematically, okay? And those are used with the concept of permutations and combinations. So we'll start talking about permutations first. A permutation of a group of symbols is any arrangement of those symbols in a definite order. Now those symbols can be anything from people to letters to cars to anything. So don't think symbols is like, X and Y. No, I'm talking about literally anything. Okay? But they're the arrangement of those items in a definite order. Okay? So suppose you have three letters, A, B, and C. What is the total number of arrangements of these three letters? Okay? I want you guys to think about it. If you need to jot it down, go ahead and do so. But I want you guys to tell me what is the total number of ways that I can arrange these three letters. How many ways?
6.
Yes, 6. The number of ways in arranging indistinct objects in a row is n factorial. Raise your hand if you actually listed them out. Okay? Now, heaven forbid I asked you for the entire alphabet. Okay, you wouldn't be able to list out all of those different arrangements. But knowing what you know now in a similar fashion, the number of ways to arrange indistinct objects in a row is n factorial. So if I wanted to ask you, what I gave you all 26 letters of the alphabet, I asked you what's the number of ways to arrange those letters. What would you do?
26.
You do 26 factorial. Type that into your calculator and get whatever that answer is. Something probably ridiculously large. Okay? But now you know. But what if you have 5 letters and you want to find the number of possible arrangements of just 3 of those letters? Just 3. Think about it. All right, what kind of answers do we have?
The wrong one.
Try.
I have 114.
114, 118.
Why would it be 3 times 3? That's 9.
Anybody answer? Other answers? Don't be shy to say something. 9, 30.
No. Oh, this is too low. That's 9 times 9.
Look at number in the thousands.
That feels I know. What's this 5 factor?
Okay? Think about it. I have 5 letters that I need to arrange, only 3 of them. So that's 3 places where I need to arrange 5 letters. Now the way that I would think of it, I would think to myself, okay, well I technically only have 3 spots, but I got 5 letters to choose from, right? That's 5 for my first spot. Once I choose one of those letters, I can't use that letter again, which means how many do I have for my second spot? And then once I choose those first 2 letters, that only leaves me with how many to choose from for my third spot. And what do you then want to do to these 3 numbers? Now this is how I would process and I would think of this. What's 5 times 4 times 3? 60. Mathematically, how that works out is by the permutation formula here. The number of permutations of R objects out of N distinct objects is given by this formula. It can either be seen as NPR with the 2 subscripts, or NPR with N as the superscript and R as the subscript, N factorial all over N minus R factorial. Okay? These are permutations. They have a definite order. So I had 5 letters to choose from, and I wanted to arrange them, only 3 of them. So 3 was my R, 5 was my N. 5 factorial breaks down to be 5 times 4 times 3 times 2 times 1. 5 minus 3 is 2. So then it turns into 2 factorial, which is 2 times 1. Those cancel, and then I'm left with exactly what I showed you. 5 times 4 times 3. Okay? The amount the amount that you want to arrange. Okay, so let's say you had 12 dogs, right? And you only want to pick 4 of them to take a picture of, okay? You will use permutations here where n would be 12, r would be 4, and that will give you the number of different ways that you can arrange those 12 dogs only using 4 at a time. Okay? Questions? Now this can be done in your calculator, so let's pull out our calculator. Okay, pull out our calculator so I can just show you. Because sometimes these numbers might be so big that it's not something as simple that can cancel out where it's just 5 times 4 times 3. Okay? And if you are allowed to use the calculator, hey, why not? Save some time. So what you do is you start with your n. In this case, with the 5 letters, I'm going to type in 5. And then we're going to go to math. Math is located right underneath the alpha button. And then you go over to PROB, or PRB, depending on what version calculator you have. And as you see, you have number 2, where it says NPR. You go to option 2, and then it pretty much looks just like the subscript order. What do you think that second box is? R. R was 3. 5 letters, I'm arranging 3 of them. And then I get the 60. So it can be done in your calculator. All right? Remember, math and PROB was exactly where the factorial was located that we talked about last week. Okay? So prob is where we're going to get like the majority of the things that we're talking about with, factorials, permutations, combinations, et cetera, et cetera. Okay? Let's take a look at this example. We're going to be doing a lot of examples today just to make sure you guys have it, okay? This one, you don't necessarily have to write down, okay? But let's do it on your desk.
3 hours.
All right, for this one, what'd you get your answer to be? Read the numbers from left to right.
5, 1, 8, 9, 8.
Okay, very good, because you have 16, that's supposed to be teams, not terms, I apologize. You have 16 teams, okay? They need to be arranged to fill the top 8 positions. So that's 16 permutation 8, written either way as a 2 subscripts or a superscript and a subscript. So then that's 16 factorial all over 8 factorial once you do n minus r, and that is how you get that number there. Very good. Clear your desk. Let's try this one.
Make it more painful.
Okay? Do just A, and then we'll talk about B, C, and D. Okay? So do just A, and we'll talk about B, C, and D. How many different permutations are there when you have alphabet blocks A, B, C, D, and E placed in a row in front of you? 120. You got that because of what? 5 factorial. Because again, once you place one of those 5 blocks first, then you have 4 blocks to place. You choose one of those, then you'll have 3 to choose from. You'll place one of those all the way down till you get to 1. So yes, you have 120 different ways you can arrange those 5 blocks, okay? There's no restriction on, I only want to use 2 of the blocks to put in a row, okay? It's set off 5. Now it's asking for how many permutations end in C. How many end in C? Think about it a little bit before you start trying to mathematically figure out. You know what for sure.
The last one's C.
There are 120, but the thing is say it again. Okay.
Well, isn't it? Well, C is always the
C is going to be at the end, no matter what. Because C, it says that C has to be the end. Okay? With C being in the end, and that's the only restriction that we have, what can we do here? Subtract 1, so then that gives me 4 blocks to work with. And what am I going to do here? Say again?
4 factorial.
4 factorial. Because if C has to be at the end, it doesn't matter the arrangement of the other ones. So you have 4 factorial ways to arrange the other 4, but C has to be that last one. What's 4 factorial? 24? 24. Very good. What about this one? How many permutations have to form block, then A, another block, then B, and then your last block? Say again? 6. Because no matter what, these are staying where they are. But the other 3 blanks can be any of the 3 blocks. So that's 3 factorial times 1 essentially, which you don't have to put, but we are taking consideration this first one represents the A block and that second one represents the B block. So how many again? 6. And what about D? I want you guys to brainstorm D before we actually talk about D. Everybody knows what a vowel is, correct? Okay, so let's see which one of y'all's right, because I've heard some good things, heard some good conversations. How many permutations begin and end with the vowel? So we already know that we have these 5 blank spots. And no matter what, a vowel has to begin this arrangement and a vowel has to end this arrangement. What are my vowels out of my blocks? A. So in the first block, it has to be A or E for that first spot, which is what? That's 2 different ways, okay? And then the last one has to be what? It has to be one of the other ones. Whatever is that last vowel that wasn't chosen the first time. And in the middle, what? It'd be 3, 2, 1 because it doesn't matter the different ways that those middle 3 can go. But the first has to begin with a vowel, and the last has to be a vowel. So then that's going to be 2 times 3 factorial times 1, which I just wrote already, and your answer is 12.
I got something right.
Good job. Questions? You understanding? Okay. Let's keep going. Let's take a look at this one. I want you guys to do this one on you, and then we'll talk about it. I want to hear some discussion.
On me.
Okay. So, there's 6 different books arranged in a row on a shelf. And how many ways can 2 of these books, A and B, be together? So you have to take into consideration. You have the books A and B or B and A. So first off, you have to figure out how you're going to arrange those 2 books. So that is 2 factorial. Now, once you figure out how to arrange those 2 books, technically, they're not 4 spots that need to be filled. There's technically 5. These 4 other books, and then the books A, B that are together. Did everybody catch that?
Yes.
So once A and B are together, they're basically a set. And then there's still 4 other books that need to be arranged along with that set of A and B or B and A together. So then that becomes technically 5 factorial, and then you multiply those together. Now I think you guys did it a different way, but you still got there.
Yes.
I think.
We did.
I think y'all did. Okay? So then you get 240. Okay? What they did was they realized there were 10 different ways to arrange those books. You said then times
4 factorial because there's 4 other spots.
Well, get into that one. Yeah.
There's not a book made up that number.
Yeah, there is. A and B represents those other 2 spots, but no matter what, they have to be together. So technically, it's 1 spot that's taken up by A and B. And then the 2 factorial takes care of the different ways that those can go in one of those 5 different spots.
So they were in the same spot, not next to each other.
No, they weren't next to each other. But since we already know they have to be together, it doesn't matter where amongst this line they're going to be. No matter what, they're going to be together. How you feeling? Okay?
I feel good now, but I know as soon as I get my
I
homework,
think we'll
it's gonna
get
be
there
struggle.
eventually.
Okay. All right. Now, one thing we have to take into consideration is when you have repeated symbols, such as repeated letters.
Oh,
Consider the word calculus.
Bad.
If you notice, calculus has
Too many.
2 C's, 2 L's, and 2 U's. How many permutations can be formed using all the letters? We should kind of know this by now. Okay? How many different ways can we arrange using all these letters? There's 8 letters, right? So there's 8 different ways to arrange those letters, but there's only 4 unique letters, right? There are 2 C's, 2 U's, 2 L's, an A and an S, correct? So you have to take that into consideration and then divide the number of different ways that you can arrange those 8 letters. Take into account you got 2 C's, 2 L's, 2 U's, 1 A, and 1 S. Somebody figure that out for me. What's his number?
I got 5,040.
1. There's one way to do it.
5,040. There's 5,040 different ways that you can arrange all the letters. Okay? Because that U, the first U, is the same as the second U. Okay? It's not like one's a capital and one's lowercase. Same letter. Okay? That formula to arrange the total number of distinguishable permutations is what you see there in the red. Where N sub 1 is the first symbol, N sub 2 is the second symbol, and so on and so forth till you get to N sub R of the arc and final symbol. So in other words, anytime you have repeated symbols, repeated letters, repeated books, numbers, whatever, okay, you have to take into account there's different ways that those two can be arranged, okay, that first U versus that second U, first L, second L, so on and so forth, okay? So let's go back to that calculus example. We know there are 5,040 different ways to arrange the word calculus, but what if A has to be first and S has to be at the end? How many different ways can we arrange, or how many permutations can be formed with A at the beginning and S at the end? Or what about with C at the beginning and L at the end? I want you guys to brainstorm those, figure those out. All right, so consider the word calculus. How many permutations can be formed which start with A and end in S? So for B, you basically have A and then how many letters in between? Okay. So no matter what, A has to be first, S has to be at the end. 1,440? Answer should be 90. How'd you get 90?
So I knew there were 6 spots between, so I just did 6 factorial divided by 2 factorial times 2 factorial times 2 factorial.
And why all these 2's?
Because the other letters that are in between repeat.
Uh-huh. In between, you basically have 2 C's to choose from, 2 U's to choose from, and 2 L's to choose from. So there you go. No matter what, that A is always at the beginning, and that S is always at the end. So there you go. So your answer is 90. Make sense? But what about with this starting with L? Starting with C and ending with L. If it starts with C and ends with L, those are one of those repeating letters. So what we get for this one?
360.
How so?
Oh, because the 6 letters in between don't always repeat themselves. It's just the U that repeats itself, so it would just be 6 factorial over 1 times 1 times 2 factorial times 1 times 1.
Very good. Very good. Those 2 U's for that 2 factorial for those U's, but then there's only 1 C, 1 L, 1 A, and 1 S that needs to be arranged. So then you get 360 different permutations.
Yes, this one's right.
Questions? Permutations, how you feeling?
Andy.
Permutations with a definite order. Okay? But there's also combinations.
Ah, yes.
A combination is a selection of objects without regard to order or arrangement. Without regard to order or arrangement. That's what a combination is. You have permutations and combinations. Okay? Okay. So let's take a look at this example. Okay? The possible teams of 3 people selected from A, B, C, D, and E are what you see in the orange. Okay? Notice that, yes, ABC was listed, but not ACB or BAC or BCA or CAB or CBA. Okay? Those are all different permutations of the players, like Logan was saying, but they are all the same combination. Okay? So, yes, distinct. Don't double up. Okay? ABC is the same thing as saying CBA. Okay? That is a permutation. So the number of, that's a combination. My mistake. You be careful on how I use these words. The number of ways of choosing when order is not important are objects from n distinct objects is combinations. Now, if you notice, there's an additional different way of writing combinations, as you can see here with this like parenthesis notation. But no matter what, these first 3 ways are just ways to represent combination. But what you see at the very end is the formula for combination, which is n factorial. So your n distinct objects divided by r factorial, the number of ways you're going to choose a certain number of objects, times factorial times n minus r factorial. A slight change in difference in the permutation formula and then the combination formula. Both permutations and combinations is in your reference booklet. And you see this notation used in your reference booklet. Okay? This notation, this is how you'll see it in your calculator. And then this notation, to be honest, this is used like close to everywhere else in other subjects, online, Khan Academy. Okay? So just realize those are the different ways, again, to all represent the exact same formula, which is given to you in your reference booklet. Okay?
What was that middle one where the N is
Superscript? That's what's in your reference booklet. So you'll see in your reference booklet, you'll see it like this, and then you'll see the formula. And so just know that that's just how it's represented. Okay? So in IB exams and things like that, that's exactly what you'll see. You'll see something like this, and then you'll need to know the association between the two. Okay? All right. So we're going to look at a few examples that deal with combinations, and maybe you'll start to, kind of tell the difference in these examples of when to use combinations versus permutations. So in this example, how many different teams of 3 can be selected from a squad of 8 if there are no restrictions and if the team must include a captain? How many different teams of 3 can there be selected from a squad of 8? Well, without restrictions, I'll do this one with you because I think I want you guys to try to last by yourself. Yeah. Okay. There are no restrictions, and if you think about it, think of this as an association with the A, B, and C people trying to make 3 teams. This is here. This 2 is combinations. Okay. I have 8 people to choose from, and I need teams of 3. Okay. 8 teams, but I need to choose 3. So that's 8 combination 3. Do I need a calculator here? No, because it's nothing but 8 factorial all over 3 factorial times 8 minus 3 factorial, which is what? 5 factorial. So that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1, 5 times 4 times 3 times 2 times 1. What do you see? I can take out the 5, 4, 3, 2, 1 on both. What else do I see? Don't need a calculator here. Huh? The 6 and 3 simplify to be just 2. What else? 2 and the 8 simplify down to be 4, and I'm just left with 1 now in the denominator. So really and truly, this is nothing but 4 times 7, which is 28 times 2, which is 56. So there are 56 ways, without having picking Bob, then Brian, then Billy, and not Billy, Bob, and Brian. You see what I'm saying? Okay? So, I don't even know where those names even came from. But there's 56 ways to basically select teams of 3 from 8 different people. But what if one must include a captain? So then that means, what, say again? So that means now that there's 7 instead of 8, because one of those people has to be a captain. So that means that once that captain is chosen, that leaves you only 7 to choose from, and how many am I choosing at that point? I'm choosing 2, because that captain has already been chosen. One person is going to be that captain, and then from there I have 7 people to choose 2 from. Okay? No calculator needed here. So this is nothing but 7 times 6 times 5, 4, 3, 2, 1, all over 2 factorial. Then what's 7 minus 2? So that's 5 factorial. What do you see? I can take out the 5 factorial, so 5, 4, 3, 2, 1, and 2 and 6 reduced down to be. So I am left with 7 times 3, which is just 21. So once you pull a captain, once you decide who that one person is going to be, okay, you got 21 ways to make a team of 3. Simple enough? Be cautious. Make sure you're doing combinations when you need to, permutations when you need to. Last example, but I want you guys to do this one on your own. Anybody ride horses? An equestrian team of 4 is to be chosen from 7 males and 6 female riders. How many different teams can be chosen if there are no restrictions? There must be 2 riders of each sex, and at least 1 rider from each sex is required. Find my number of different teams. All right, so equestrian team of 4 is to be chosen from 7 male and 6 female riders. So how many different teams to be chosen if there are no restrictions? There are no restrictions on their gender. How many riders do they have altogether? So how many riders do they have to choose from? 13 to choose how many? 4. So that's 13, choose 4, or 13, choose 4, or 13, choose 4. Either way, it's all the same thing. How many different ways? There are 715 ways that there are no restrictions, but they put a restriction on there that 2 riders there must be 2 riders of each sex. So 2 males, 2 females. Okay? So for the men, how many men do we have? We have 7 men to choose how many? What about the females? To choose how many? 2. What am I going to do with those numbers? Find them and you multiply them. Yes, you do multiply them because together they make our team. 2 men and 2 females from however many different ways. I can pick 2 guys and two ladies. How many?
525.
525.
I got 4, 45.
Whoa! What are y'all doing?
Oh, I got 215. Is it
315. That sounds a little bit better. Y'all give me numbers in the thousands. I'm like, what's happening? We doing 7 math PRB. Option what? Option 3 for NCR. Exactly. Like, how does that increase? But look at your answers. Make sense. Does it make sense? Okay. Now this one, at least one writer of each sex is required. At least, which means you need to have at least one guy or more, and at least one female or more. So let's just kind of talk about it before we start putting in combinations. What are the different ways we can have a 4-member equestrian team where at least one member of one gender is required? One of each gender is required. What are the different ways? Talk it out. How can it happen? You can have 3 males, 1 female.
2 to 2.
Okay, so I got 715.
You can have 3 females and 1 male. 2 females or 2 males, okay? Which we just figured out. So we already know what that one is, right? Because this is the same one from part B. So we already know that's 315 ways. If I'm choosing 3 males and 1 female, so how would I write that in combinations? Using combinations, how could I write 3 males and 1 female? Not 3C1. How many males do I have to choose from?
7.
7. And I need to choose how many? 3. What about my females? 6C1. And what do I need to do to those 2? Multiply them. Can somebody tell me what that number is? So we got to start with how many we have overall. Okay, so there's 210 ways I can choose 3 males and 1 female. Unfortunately, that's not going to be the same for 3 females and 1 male because my numbers aren't equal. Okay, so for my 3 females, that's going to be 6 choose 3 and 7 choose 1. And what am I going to do to those 2? Multiply them. So give me that number of different ways I can have them. 140. So there's 210 ways I can choose 3 males and 1 female, 140 ways to choose 1 female and 1 male, and 315 ways I can choose 2 males and 2 females. What is my total number of ways I can have at least one writer of each sex be required? And what did you do to all 3 of these numbers? Add them. So your total number is 665.
I did it differently and I still got it.
Okay.
So, like,
Say it again.
so I took the unrestricted answer
Took the unrestricted answer.
and then I subtracted all the ways that you can have 4 of one gender.
So took the non-restricted answer and then subtracted the number of ways to get 4 males
And 4
and 4 females. Because we want at least one of each gender, which means I can't have any of these. So yes, that would also get you 665. Good way to think about that. Very nice. Okay? Good job. That will work. Every time. Okay? So, combinations and permutations. When do I use which? When do I use permutations versus combinations? Which one do I use when order is important? Okay? So when order is important, I'm going to use permutation. And when order is not important, that's when I'm going to use combinations. Very good. Factorial is involved in this because it's a part of their formulas. It is the process of multiplying a number by each number decrease all the way to 1. And product and sum principles are what we talked about last week. So remember, this loss will be a 1. I should know better. Okay? And there we go.